Okay, second try. Unit 6, Lesson 1. We're going to start working on ratios and proportions. Khadija, what are equivalent fractions?
Equivalent fractions are fractions equal to each other.
They're fractions that are equal to each other. Another way the book explains it is equivalent fractions are fractions that name the same amount. Okay, an example of that would be 2/4 is the same as 1/2. You can just slide your desk over. Okay. Can somebody simplify 2/4 for me? And actually, somebody simplify 2/4 for me. Go ahead. It's equal to 1/2. I have a typo here, but I do want to walk you through this part. So 2/4, 2 I can rewrite as 2, and 4 I can write as a factor of 2 times 2. Do you guys understand that? And then these two factors cancel out, and I actually have a typo. And that's equal to 1/2. Okay, are we good? All right, who can give me number 3 in simplest form? Nima? 7/9. Let's walk through how we do that. So what was the factor that you divided the numerator and the denominator by? 3. So we can think about it this way. 21 is the same as 3 times 7. 27 is the same as 3 times 9. That means our factors of 3 can cancel out, so we get 7/9. And remember, if we have something in the numerator, the denominator, they just become 1. Okay? Yes. Okay, who's got the next one? Go ahead, Miranda. 4/7. So what did you divide the numerator and the denominator by to get 4/7? 9. So here we go. 4 times 9 is 36. 7 times 9 is 63. And so we get 4/7. And my 9s actually would cancel out. Okay. And then 8/24. Gabby? 1/3. Very good. And so the way we can do that is we can rewrite this. 8 stays the same. 24 is 3 times 8. And the 8s cancel out. We get 1/3. So these two factors cancel each other out. Okay? Moving on to what we're covering for today. All right. I'm going to go and read this since I'm going to try to use this video for the YouTube channel. What you'll learn. To write ratios and use them to compare quantities. New vocabulary. Ratio, equivalent ratios. Why learn this? The keys on a music keyboard have a repeating pattern of 5 black keys. 1, 2, 3, 4, 5. And 7 white keys. 1, 2, 3, 4, 5, 6, 7. So in the red box, this pattern repeats again over here, and it continues on. Do you guys understand what's going on? It's a repeating pattern. So the ratio of black keys to white keys, black keys, there's 5, and white keys, there's 7. The pattern is 5:7. Do you guys understand? Okay. What is the ratio of black keys to all the keys in the pattern? So we're going to talk about that here in a moment. But before we move on, I want you guys to talk about the key concept. Okay. So if you notice right here, total we have 12 keys altogether. You understand that? There are 7 white keys, 5 black keys. So altogether we have 12 keys. So the key concept, ratio. A ratio is a comparison of 2 quantities by division. You can write a ratio in 3 ways. Arithmetic, here we have 5:7. That's the ratio of black keys to white keys. Or 5:7. That means the same thing. Or you can write as a fraction. Does that make sense? Okay. And algebraically, same deal, except for b can never be 0. Just like on any fraction, you can never divide by 0. You can never have a denominator equal to 0. Does that make sense? And we've already discussed this in the past, but make sure you understand that. So that's the key concept. Now we're going to answer this question in the next slide. So, using this pattern, write the ratio of black keys to all the keys in 3 different ways. So we're not talking about ratio of black keys to white keys like we did earlier. Now we're talking about the ratio of black keys to all the keys. Can somebody share with the class what they think that's going to be? Joel. Nice, 5 to 12. So the ratio is 5 to 12. What's another way I can write it? Here's my first way to write it. Robert. A fraction, very good, 5/12. And there's one more way to write this. Go ahead. With a colon, very good, nice, 5 to 12. Okay, these all mean the same thing. Do you guys understand? Okay, so we're talking about 5 black keys to all the keys in that pattern. There's 12 keys total here, and 5 of them are black. Does that make sense? Okay. Now, read this question and answer this question to yourself. Now, I noticed on the quiz and the test, some of you guys are struggling with the word problems, so I don't want to read this part to you. I want you guys to try it on your own. When you're done, put your pencils down, but I want you to write out the ratios, the 3 different ratios that answer this first question. I would say a third of you, for every 1 student, there's 2 students not writing out the answer to this question. And that ratio is pretty lousy. I would like to see a better ratio than that. So we're using this picture right here to answer this problem right here. Mm-hmm. That's the pattern that repeats, yes. So we're just looking at that. In the back, yes, Cruz. 7 to 12. So using the pattern shown above, this right here, you're going to write the ratio of white keys to all keys in 3 different ways. So 7 to 12 is one way. There are 7 white keys out of 12 total keys in that pattern. What's another way we can write that? Go ahead and finish it up. What's the other ways we can write that? With a colon, right? 7 to 12. And then what else? Fractions, 7/12. Okay, now we have something a little different down here. Read this part and answer this question. Somebody I haven't heard from yet. Marcellus, can you give it a shot? Seven to what? 20. No, we don't have 12 in the pattern, or we don't have 20 in the pattern. There's 12 in the pattern. Atisha?
7 to 5.
7 to 5. So we're talking about white keys to black keys, and there's 7 white keys for every 5 black keys. Do you understand? Very good. What are the other 2 ways to write this?
7 to 5
With a colon, right? And then
7
as a fraction, right? 7/5. Okay. Any questions about these? Go ahead.
ratios, which number comes first? Like the bigger number goes first?
They're going to tell you, like here, they said the ratio of white keys to black keys, so the white keys are what's first. So in the first example, they said the ratio of black keys to white keys. So that's why 5 was first and 7 was second. Yes?
For a fraction, if there's another numbers like that, like a greater,
You want it in simplest form, but keep it as an improper fraction, okay? Because we're comparing for every how many of this, I have something of that, okay? So this is a little different than parts of a whole. So you guys see the pizza on the wall? If I'm talking about 1/4 of a pizza, I'm talking about 1/4 of a whole pizza that's been cut into 4 parts. Does that make sense? Here I could be comparing different things. Do you guys understand? Here, for fractions like we've learned in the past, we were talking about parts of a whole. So we weren't talking about 2 different things. Does that make sense? Here we're like talking about like, okay, if I have this amount of this thing and this amount of this thing, what's the ratio? Okay? So it's a little bit different. You're not necessarily comparing the same thing with ratios and proportions. All right, moving along. 2 ratios that name the same number are equivalent ratios. You previously learned to write equivalent fractions. You can find equivalent ratios by writing a ratio as a fraction and finding an equivalent fraction. So what that's saying. Can somebody explain to class what they think that means? Noah? Sorry. Mason?
It's like when you convert it to the fraction form, you can easily find the equivalent fraction or simplest form of thing.
Very good. So let me see if I can reword what you just said. So you're saying if I have the ratio in fraction form and I find an equivalent fraction, then I also have an equivalent ratio. Do you guys understand what he just said? Okay, is that what you're trying to say? That sounds pretty close. You're almost spot on. All right, so now with that in mind, here's my example. Write equivalent ratios. Find a ratio equivalent to the following ratio. We have 4/5. Now, let me ask you this. If you have a fraction, is there only one equivalent fraction to that? No, there are infinitely many. So some of you might have the same answer that I'm going to come up with. Some of you guys might have a completely different answer, but it can still be an equivalent fraction. Jameson, can you give me the equivalent fraction of 4/5? Robert, can you explain to Jameson how do we find an equivalent fraction? Okay, so let me reword what Robert said. If I multiply the numerator and denominator by the same number, I'll get back an equivalent fraction. Or if I divide the numerator and the denominator by the same number, I get back an equivalent fraction. So can you, now that Rob's reviewed with you how to find equivalent fractions, can you tell me an equivalent fraction of 4/5? You could pick any number. So what do you want to multiply 4 and then 5 by? It's got to be the same number. Give me any number. 2. Okay. So what's 4 times 2? What's 5 times 2? 10. That's not, you didn't have to pick 2. You could have picked another number. Can you pick another number? Okay. So if you pick 3, what would my equivalent fraction be if I picked 3?
12.
That's also an equivalent ratio. Do you see how easy that is? Okay. I packed them and I don't remember where I put them. Write the ratio of 2 yards to 20 feet as a fraction in simplest form. Now, we're trying to review some things. Do you guys remember for every 1 yard, how many feet do I have? I see it. Some of you guys are making it. It's this many, 3. So for every 1 yard, you have 3 feet. So what I need you to do is I need you to rewrite this as a fraction, but you can't have it that the numerator is a different unit than the denominator. So you have to convert. So can you guys convert it so you have the same units? Let's make them all feet. And then let's get this in simplest form. So before everybody starts throwing their hands up, I want you to try and work this out. Okay, who can walk us through this? Write the ratio of 2 yards to 20 feet as a fraction in simplest form. So first of all, I wanted this all in feet. So if I'm going to write 2 yards as feet, how would I rewrite that? Can I get somebody to explain that to me? Bryce, how many feet do we have if we have 2 yards? 6, nice. So what you have to know is this fact right here, that 1 yard equals 3 feet. So that means 2 yards equals 6 feet. So I'm going to go ahead and work that out. So we have 2 yards to 20 feet. We rewrite that. Since we have 3 feet per yard and there's 2 yards, 2 times 3 gives us 6 feet per 20 yards. Now, it says to rewrite this in simplest form, right? Okay, so Bryce, what do I get when I rewrite this in simplest form? 3/10. Okay, are we good? Question? Oh, you want to do the next one? Okay, well, we're not quite to the next one yet. Does anybody have any questions on this problem? Okay, so now that I've worked out the example for you, I want you guys to try and do these 2 problems. And notice we have gallons to quarts. I'm going to go ahead and give you that a little bit of help. Can somebody tell me how many quarts there are in a gallon?
4.
Okay, so you guys should be able to finish that up now. Okay. Who can give me an equivalent ratio to 7 to 9 or 7/9? Tata.
So I got 2/10, and that equals to
Wait, which one are we doing? We're doing this one? So you got 12/10. Okay, so you're okay, we can skip to the next one. So here's what we have, 3 gallons per 10 quarts. And then you rewrote that as 12 quarts to 10 quarts. Okay, simplify that.
and that's
6/5. Okay? Now notice we're talking about the ratio, how much of one amount to another. So we're gonna leave it as an improper fraction. Okay? Who can explain their answer for this one right here? Who's got this one? Somebody I haven't heard from yet. It would be nice. Alexia, you have any equivalent fraction to 7/9? 21/27. Perfect. That's one. What was the number you multiplied the numerator and denominator by? So you multiplied the numerator and denominator by 3. So that's another example. So 7 times 3 is 21. And then 9 times 3 was 27. So this is also equal. Very good. Got another one?
35/45.
Okay. This is also equal to 35/45. Did anybody get another one? Michaela? 14/18. So we got that one. That was the one I gave, but that's okay. Anybody got a different one? Go ahead. 70/90. Okay. All right. And we could go on and on. These are all equivalent. But what I want to move on to is comparing ratios. So let's take a look at this example. Pens over there. Let's take a look at this example. Social studies. An official U.S. flag has a length to width ratio of 19:10. The largest U.S. flag measures 500 feet by 255 feet. Is this a U.S. flag? So there's a couple ways we can check. I'm not going to explain to you how. I'm going to let you guys try to figure that out. Take some time. Try to tell me, is the largest U.S. flag, is that an official U.S. flag? Use your problem-solving skills. There's more than one way to do this. I'm going to give you guys about 60 seconds to work this out. Chin, notebook. So who had a strategy to see if this was an official flag? What was your strategy? Robert, what was your strategy? See if 10 can go into 255, and it can't. I think there's probably an even easier way to think about this. Who had another method? I'm gonna give you a really.
It's Charles Banks here.
Yes.
Okay.
Yep. So here's our method. You guys know how to divide by a power of 10, correct? If we divide by a power of 10, what's our quick mental method if we're doing that? Not take a 0 off. It has something to do with the decimal. Okay, so Tata says move the decimal. Tata, which way am I going to move my decimal? If I'm dividing by 10, am I making it bigger or smaller? No, that's multiply, make it bigger. If I'm dividing by 10, I'm actually making it smaller. So which way am I going to move my decimal to make it smaller? Left. And how many places? How many zeros are there in 10? 1. So we only move it one place and we move to the left. So what would this be equal to? If I move my decimal one place to the left. Somebody? Anybody? 1.9 or 1 and 9/10, right? That's something you should be able to do mentally. We've talked about that shortcut a number of times. Okay? Now, if I want to figure out the decimal equivalent of this fraction, I would just divide it. Let's go ahead and divide it. If you're on top, are you in the house or out of the house? In the house. So I got 505 in the house and 255 out of the house. So let's go and work this out. How many times does 255 go into 505? Once. If I double 255, that's going to be 510. That's too much. So we're going to go in one time. So 255. Subtract that. 5 minus 5 is 0. Can I take away 5 from 0? No, I got to borrow. So 0 becomes a 10. But it can't become a 10 unless this becomes a 4. So 10 minus 5 is 5. And then 4 minus 2? 2. Now, if you look, we ran out of numbers, right? And so do you guys remember what we call that? We have to fix that. Do you guys remember what we call that? Nice. You guys are remembering that. We're going to annex some zeros. But before I annex some zeros, I have to do something. I have to put a decimal. I'm going to put a decimal right here, and then I'm going to annex my zeros. So place my decimal. Annex my 0. This decimal has to come straight up, and I'm going to lengthen this off a little bit. Okay. Now, I'm going to bring this 0 down. And how many times will 255 go into 2,500? 9 times. So if we take 9 times 5, what do we get? What's 9 times 5? 45. So we put a 5 here, and then I carry the 4. 9 times 5 again, 45 plus the 4, 49. Carry the 4 again. 9 times 2, 18 plus the 4, 22. So we're going to subtract all that. Well, when we subtract all that, I can't take away 5 from 10 because I got to borrow, but I can't borrow from the 0 because it's a 0 and I don't want a 0 above my 9. So I'm going to borrow from the 5. The 5 becomes 4. This becomes a 10, but I got to borrow from this 10 to make this a 10. So this becomes a 9. Okay, do you guys understand what just happened? So in order to make this 0 into a 10, I had to borrow from here, but it was 0, right? So I had to borrow from the 5 to make that a 10. Now this became a 10, and to borrow from that 10 to make this 0 into a 10, that became a 9. Borrow from 5 twice? Well, hold on. Let's walk through this and we'll see I will come back to that if we have time. 10 minus 5 is what? 5. 9 minus 9? 0. 4 minus 2? Who said 3? It's 4 minus 2. 2. And then 0 minus 0? Nothing. Now, I have to annex another 0, so I'm going to go ahead and do that. And I'm going to bring that down. How many times will 255 go into 2050? Well, we saw 9 times 255 gave me 2,295, right? So would 8 work? No, it'd still be too much because if I subtract 255 from this, it would be what? 240, right? That's too much. So 8 is too much, so 7. If we try 7, let's do 7. 7 times 5, 35. Carry the 3. 7 times 5 again, 35 plus the 3, 38. And then carry the 3 again. 7 times 2, 14 plus the 3, 17. Okay, so we don't need to continue anymore. Do you know why? Can't we already see that these are not equal? Right? So this ratio does not equal this one. It's actually greater than. Right? And because it's greater than, guess what that means? It's not an official flag. Do you guys understand? Yep. Does 8, I don't think, is 8 2, 8 would have been 240? But, oh, it would have been okay? Didn't I say 240? Why did I don't know what I was thinking. I'll fix that. Let's fix that right now. So that should have been 240. You like my eraser? It's a first aid kit. Okay, so you said 8 worked? I don't know what I was thinking. Sorry, I'm still on break. So 8 times 5. Oh, we already said it's 240. 2040. Subtract, that's going to be 10. But that doesn't matter because it's still going to be greater than, right? So my answer is still, it's since 1 and 9/8 is not equal to 1.9, the largest flag is not an official U.S. flag. All right, so moving along. Really quickly, I need you guys to tell me if these ratios are equivalent or not. Take some time. Yep. Yeah, but I talked about a shortcut here. 19 divided by 10 is 1 and 9/10. Okay, and when I divided this out, that's what I got back. Now, this is, I don't need to divide anymore because I can already see that this is a larger amount than the first fraction or the first ratio. Does that make sense? So it's not an equivalent ratio. All right, same strategy. I want you guys to identify if these are equivalent ratios or not. Take some time. Here's another way we're not going to talk about it just yet. I know. Yeah, can I? If I send you to the office, there's no nurse. They said it's an emergency. They're going to call your parents, and your parents have to come pick you up. So you tell me what you want to do. So is this first ratio, is this equivalent or not equivalent? Why do you say not equivalent? 7 doesn't go into 128. Does 3 go into 54?
Yes.
How many times? 18. So let's rewrite this. So if I rewrote this as an equivalent ratio, you're saying that instead of a 3, I could say 54. And what did you multiply by 3 to get 54? 18, right? So times 18. And what's 18 times 7? 126. So since these are not equal, it's not equivalent. Okay, let's take a look at this next one. Are these equivalent or not equivalent?
No. Wait.
Why do we say not equivalent?
34 is not an even number.
You know, that doesn't always work. You can't look at the numerators and denominators and say, well, this one's got an odd number, so that one doesn't, so they're not equivalent. You can't always do that. I'll give you an example. Look, 1/2 and 5/10. Odd numerator, right? Oh, that's not a good one. Let me give you a better one. 4/8. There we go, that's better. Does that make sense? So that strategy you're saying doesn't always work. All right, so can you, who's got a strategy for this? If you don't have a strategy, then just divide them and convert them to decimals. If you do have a strategy, what's your strategy?
First thing I did was take off the zeros and
Okay, so you said, hey, this is equivalent to 18/24. Okay, go ahead.
and then after that I tried to see if both of them divided by 2.
Okay, can I divide both of them by 2?
Well, yes, except 25 and 25 to 34.
Okay, so you can't divide that by 2, but you can divide this by 2. So what did you say this is equivalent to? 9/12. And then you said that's 3/4. Okay, so what did you do with that? Where'd you go from there? You said 3/4 and 25/34. Can I rewrite? What would this equal here? What's 3/4 equal to? If I wrote that as a decimal. 0.75, right? Or that's the same as 0 and 75/100. So I could divide that out and figure out if they are equivalent. So we have the numerator. If you're on the top, you're in the house. So this is there are many methods, but I'm just going to go over one method. This unit's going to talk about some other methods. We'll get to those later. So first of all, if you're on the bottom, you're out. If you're on the top, you're in. Can 34 go into 25? No. So we got to annex some zeros like we talked about earlier. How many times would 34 go into 250?
7.
7 times?
You get to 22/8.
228. Is that what we get? Okay. And so, wait, 7 times 4 is 28. Carry the 2. 7 times 3 is 21 plus the 2. So what's this going to be? 23. Okay. So we have 238. So watch when you carry. All right. So let's go ahead and subtract this. We have the bar. That becomes a 10. This becomes a 4. 10 minus 8, what's that going to be? That's going to give me back 2. 4 minus 3, 1, and then 2 minus 2, 0. I got to annex some more zeros, right? So I'm going to add another 0. And I forgot to bring my decimal up. Now, if this is more than 5, then it's not going to work, right? So I'm going to add my 0, 120. How many times does 34 go into 120? Noah? You're saying 3 times. So if I take that and I say 3 times, use 3. 3 times 4 is 12. Carry the 1. 3 times 3 is 9 plus 1, 10. Subtract that. But you know what? Already we have a difference, right? So we see that this fraction right here is actually less than the other fraction. So these are not equivalent. Okay, what about this last fraction? Or this last ratio? What is that? Are they equivalent? Are you sure?
I think they are.
They actually are equivalent. And I'm going to leave that up to you guys to verify. Yes. Equal ratios. Okay? These two are equal ratios. You guys can verify that on your own. I want to move along to the last slide. How are equivalent ratios like equivalent fractions? Who's got that answer?
Both equal.
I'd like for you to use a different number, different word besides equal. Tata, help out. Bryce, in the back, it seems like you might have an answer. You got an answer for me? How are equivalent ratios like equivalent fractions? Nice. They have the same amount, same value. Equivalent ratios need the same amount as do equivalent fractions. Okay, number sense. Do all ratios compare? Actually, Mason was next. You can go after Mason. Number sense. Do all ratios compare a part to a whole? Explain. Does somebody have this answer? Do all ratios compare a part to a whole? No. Fractions compare a part to a whole, but ratios, they can compare different things, right? So, no, ratios compare any two quantities. For example, a ratio may compare two parts, just like we saw with the examples for the piano, okay, for the first examples. Find an equivalent ratio for each ratio. Can somebody give me an equivalent ratio to 1 to 8? Miranda? 2 to 16? Did you have a different one?
I said 4:30 seconds.
4:30 seconds, that's another one. So, good. That's also one. I give a sample answer. What about 2 to 7? Who's got an equivalent ratio for 2 to 7? Who's got one for me? Atisha? No? Alexis? 4/14. Good, that's the same one I had. That was an easy one. Who's got another one different than 4/14? Bryce? 14 over what? 14 over 49, good. And the factor you multiply the numerator and the denominator by was 7, very good. Okay, who's got one for 10 to 9? A different equivalent ratio. Jaden?
100 to 90.
100 to 90, nice. So you multiply the numerator and the denominator by 10. So 100 to 90, good, or 100 to 90, okay? And then a sample I give is 20 to 18. I just doubled it. Okay, so here we go. Write each ratio in simplest form. Write each ratio as a fraction in simplest form. So work these out. We're almost done. Jakari, turn your desk around and participate with the class. So how many quarts would I have if I have 2 gallons? You guys remember? How many quarts are in a gallon? 4, right? So if I have 2 gallons, how many quarts do I have? I have 8 quarts, right? So it would be 8 quarts to 14 quarts, and I'd have to simplify that. So what's 8/14 simplified going to be? 4/7. Are we good? You guys understand how we did that? Okay, now, inches and feet, we want it all to be in feet. So, if I rewrote this, or let's do, yeah, all in feet. Let me rewrite this. You know, it looks like the book gives it in feet, so I guess it doesn't matter. It'll still give you the same fraction in the end. So let's rewrite 4 feet as inches. How many inches are in a foot? 12, right? So we get 48. And then, so we get 34 to 48. And then 34/48 is going to simplify to what? 17/24. Okay. And for this last one, I got 4 minutes to every 90 seconds. So how many seconds are there in 4 minutes? No, there's 60 seconds in a minute, right? So 240 seconds every 90 seconds, okay? And if I simplify that, what's that going to simplify to? Who said it? Nope, it gets better than that. Miranda? 8/3, that's it. Okay, and then the last part of my lesson, tell whether the ratios are equivalent or not equivalent. What's this in simplest form? 1/2. And isn't this also a half? 50 out of 100, right? So if they're equal, are they equivalent? Okay, how about this? That's a trick. 1/3 is already in simplest form. 2/9 is already in simplest form. They're not equal. So these are not equivalent, right? Now I could have rewritten this as, how do I rewrite this fraction so I have a 9 in the bottom? Multiply the numerator and the denominator by what? 3. So what would my numerator be? 3/9, and you see that they're still not equal, okay, if you want to compare common denominators. All right, how about this one over here? Last but not least, 2/3 and 24/36. Okay, this is already simplified, and we might have to get common denominators, so 2/3. And then 24/36, is there a common factor between 24 and 36? 12. So 12 goes into 24 how many times? Twice. And 12 goes into 36 how many times? 3. So are they equivalent? Yes, they are. And so these are equivalent ratios.